This video is going to go over how to solve a system of equations by graphing. And when you graph a system of equations, it's nice because you can actually see what the solution is. And you can also see what type of solution there is, meaning there are systems that have one solution, no solutions, or an infinite number of solutions. And if there's one solution, then the solution is going to be the point of intersection of those two lines. So let's look at some examples. First of all, you've got one solution, you've got two lines that intersect. These are considered consistent and independent, meaning consistent, there is a solution, independent, there's only one solution. A system can also have no solutions, and this would exist when there are parallel lines. There are no points that satisfy both equations, therefore this system is referred to as inconsistent. And an infinite number of solutions would be that you've got two graphs that are exactly the same line, one on top of the other, so they overlap everywhere, which means there are an infinite number of solutions all along those lines. And these are referred to as dependent and also consistent. So consistent because there is a solution, just like one solution, but not independent because there's more than one solution. So independent is one solution, but dependent is more than one solution, in this case an infinite number of solutions. So graphically those look like this. One solution, no solutions, and an infinite number of solutions because we've got the same graph graphed on top of itself. Alright, so let's look at our first system of equations. Remember that when we graph, you are most likely going to, you are going to want to put your equation in slope-intercept form. So this bottom one is already done for us. So let's go ahead and put this top one in slope-intercept form. So I'm going to subtract 4x from both sides. So negative 6y equals negative 4x plus 12. Divide everything by negative 6. So y is equal to positive 2/3 x minus 2. Alright, so I'm going to go ahead and graph this one in green. My y-intercept is negative 2, and my slope is up 2 over 3. Up 2 over 3. Up 2 over 3. And then you can connect those. With systems of equation especially, you're going to want to extend your lines because they may not cross until way over here or way up here, so you want to extend your lines so that you can see where they intersect. My second equation has a y-intercept of positive 3 and a slope of negative 1, so I'm going to go down one to the right one, down one to the right one, down one to the right one, and you can see right there is where my lines are going to cross. So this, even though I didn't do a very good job of my line, this is my solution. So my solution to this equation is to the system is 3, 0. That means if I plug 3 in for x and 0 in for y, it's going to satisfy both of those equations. Alright, once again, I've got one that's already in slope-intercept form and one that needs to be put in slope-intercept form. So this one I'm going to add 8x to both sides. So I've got 4y Alright, 4y equals 8x plus 4. Divide everything by 4. Y equals 2x plus 1. Alright, and you'll see right away these are actually the same line. So when I go to graph them, my y-intercept is 1, my slope is 2. And when I go to graph this, I would be graphing the same line on top of itself, which means there is an infinite number of solutions. Simplifying this first one, 2y equals 6x plus 8. Divide everything by 2, and I get 3x plus 4. Graphing that one, I've got a y-intercept of 4 and a slope of 3. Graphing this one, I've got a y-intercept of negative 5 and also a slope of 3. And if you recall, lines that have the same slope are parallel lines, and they're never going to intersect. So whenever I have a set of parallel lines or my equations have the same slope, then I have no solution, because my solution is where the lines cross or intersect, and parallel lines never intersect. Both are already in slope-intercept form. First one has a y-intercept of positive 2 and a slope of 1/3. And the second one has a y-intercept of negative 2 and a slope of negative 1. So right there is where they intersect. So negative 3 comma 1 is my solution. Last one, graphing this system, I have a y-intercept of negative 3 and a slope of negative 3 over 2. So I'm going to go up 3 and to the left 2. And for the second equation, I've got a y-intercept of 1 and a slope of negative 1/2. So down 1 over 2, down 1 over 2, up 1 to the left 2, up 1 to the left 2. See what I mean about extending your lines so you can see where they intersect? Sorry, it's a little difficult with a slate. Anyways, right here is where they intersect, so that's negative 4 comma positive 3. In the coming days, we're going to look at other ways that we can solve this system algebraically without graphing, because some of them are not going to give, some of our solutions are not going to be as nice as negative 4, 3. So we're going to want an algebraic way to solve these rather than rely on graphing.